notebook. Question number 30 now. Okay, it's a very simple problem which was asked in IES. And what is the question? Read the question, all of you. For the circuit shown below, the value of capital R is adjusted so as to make the current in RL equal to 0. What is the value of capital R? Okay, very simple. Look at this. Network, you draw the network again, okay? Five ohm, 4 ohm, and expected to find this capital R value, and this is RL. Okay, look at that network once. Definitely it is a balanced bridge, right? Or bridge circuit first. Whether it is balanced or not, you can check it out. Now, because he is asking the question that balanced bridge or not, we do not know, because unless we know the value of capital R, we do not know whether it's balanced or not, right? But what is the question actually is asking? To make the current in RL 0. See, when current through RL is 0, definitely this entire circuit will become balanced. Yes or no, all of you, okay? So he is indirectly giving what? The condition for balanced only, okay? So what is the current through RL is supposed to be actually here 0. Current 0 refers to what? It's a balanced Wheatstone bridge, okay? For balanced Wheatstone bridge, 10 by 4 must be equal to what? 5 by R. Then R must be equal to what? 2 ohm. That's it. Simple. Okay? Note down. Note down. Question number 31. This is also asked in IES. Okay? Please note on that, and meanwhile I just write this problem on the board. So read the question here. If the two circuits shown below are equivalent, then which of the following is oblique R correct? Okay, so this is given actually the data. E is equal to 2 volt, R is equal to 5 ohm, E is equal to 4 volt, R is equal to 4 ohm, E is equal to 6 volt, R is equal to 3 ohm, E is equal to 10 volt, R is equal to 1 ohm. Okay, so what is given actually here? Select the correct one using the code given below. Select the correct one using the code given below. Only 1 and 2. B. Only 3. C. 1, 2, 3 and 4. D. None. Okay, this is the question given, right? Okay, I think all of you might have understood already the question given. And the first important thing that you must understand is, he has mentioned the two circuits are equivalent. So we discussed equivalent circuit concept in one of the previous sessions, especially when I explained about The source transformation I clearly described. Okay, when the networks are given, equivalent, there are two possibilities. You have the given networks. The given networks might be active or passive. Now here, active or passive? Active networks, because there is an active element. Okay. Now these two networks are equivalent with respect to what? XY terminals. Equivalent with respect to XY terminals. I told you clearly at the time, okay, that the problem will be mentioned clearly. The following two networks are equivalent with respect to the given two terminals. He is not mentioning, but he has given the XY terminals clearly. That means they are equivalent with respect to what? XY terminals. Clear? Now, when two networks are equivalent, okay, particularly two active networks are equivalent, what is the condition that we are supposed to take? So you already know that, right? What is the condition here? What is the condition? The current here, okay, and the voltage here, V. And the current here and the voltage here must be same. Yes or no? Okay, then only they are said to be equivalent. With respect to XY terminals, the current and voltage, if these two are same in both the cases, then the given networks are said to be equivalent. Okay, yes or no? Therefore, let us find the current here in the first case. What is this? 18 by 9. This is 2 ampere. 2 into 6. This is 12 volt. Yes or no? Okay. Let us maintain the same here because he mentioned these two are equivalent. This must be 2 amperes and it must be what? It must be what? 12 volt. 12 volt. Now what is the relation between this 2 ampere, this R, this E and this 12 volt? What is the relation? You know that, okay, this is 12 volts, this is 12 volts, this is E, and this voltage is how much? Because the current flowing in this particular R is I, that is 2 ampere, 2 into R. What is the voltage across it? 2R volts. Yes or no? Then what is the relation between these two? 12 volts is equal to, okay, 2R plus E. Yes or no? Agree all of you? Now you just take out of these 4 cases, which of them or which of them are or is satisfying this particular equation. You substitute E is equal to 2 and R is equal to 5. 5 into 2 plus 2, 12. It is satisfying. Yes or no? 4 plus 4 into 2, that is 12. It is also satisfying. See the first option, only 1 and 2. What does it mean, only 1 and 2? Only 1 and 2 means 3 and 4 are not. Yes or no? But look at that 3 also. 6 plus 2 into 3, 6, that is 12. It is also satisfying. Only 3, no. Also check this. Also check this. 10 plus 2 into 1. This is also okay. Therefore, all are satisfying. 1, 2, 3, 4 options are correct. Understand all of you? Okay. Only 1 and 2 means 3 and 4 are not. Only 3 means 1, 2, 4 are not. Yes or no, all of you? So, note down this. This is how you need to solve when equivalent circuit concept is. Note it, another problem here meanwhile. Classroom workbook. Question number, what is that? 32. It was asked in IES again. Okay. Read that question. In the following circuit, find the capital I value. Okay. The network is given like this, plus minus So what is this capital I value? He is asking. Okay. So look at this. I think all of you noted down this, right? Okay. Please note it quickly. Okay. It's already given in your classroom workbook, problem number 32. Look at this. He gave, he's asking what is this actually the current I. But of course, he gave one more important point. I think you see that classroom workbook. He has given here 1 ampere current. Okay. So please note that also. Please note down that also. Here it is given 1 ampere. Okay. And given 1 ampere and is asking what is the current here. Look at this, all of you. If you want to find the current here, you must know what? Voltage. Ohm's law, right? If you know voltage across these two are, you can find this current. This voltage. This voltage means this voltage because these 2 points are same. And this voltage means this voltage. This voltage means they're all zero resistance wire. This voltage. That means this voltage. So if you want to find I, you must know what is V. For that, to find this voltage, you must know voltage across this and voltage across this. To find voltage across this and voltage across this, you must know current through this and current through this. But he has given current here. Understand? Okay. So can we make use of this data and try to find the voltage and voltage? Once you find voltages here, you find voltage. Once you find voltage here, you can find current because this is nothing but the voltage across 2R. Okay. So look at this now. What is the voltage across this? 4R into 1. Yes or no? 4R into 1. Therefore, this is 4R volts. Yes or no? Now, to find the voltage here, because our objective is to find the voltage here, to find the voltage, you must know current. To find the current here, you must know current. Yes or no? Or else, let us say otherwise, how these elements are connected, parallel. How these elements are connected. Look at this. This voltage is known means this voltage is also known now. Yes or no? Okay. Of course, to find the voltage, we need current, but without knowing current also, because these two are connected in what? Parallel combination, I can say directly the voltage across this one is also 4R volts. Yes or no? Now 4R by 4R, what do you get here? 4R by 4R, you get what? 1 ampere. Why I am finding this current, you know? Because I want to know the voltage here. How would I know the voltage here? Only when I know current here. How would I know current here? When I know the current here and here, then only I can find the current here. So 4R, okay, 4R is the voltage. To find the current here, let us also find the current here. 4R by 2R, how much current is flowing here? 4R by 2R, how much it is? 2 ampere. If this is 2 ampere, this is 1 ampere, how much here? 3 amperes. If this is 3 ampere, this is 1 ampere, how much here? 4 ampere. If this is 4 ampere, then what is the voltage across it? 4 into 3R is 12R. Therefore, the voltage will become now, touching concept, okay, 12R plus, okay, 4R is nothing but 16R. So once you know this, you will find this I is equal to V by 2R, nothing but what? 16R by 2R, nothing but what? 8 amperes. Hope you all of you understand. I repeat once again. This is the data given actually 1 ampere and is asking what is I. To find I, we understand that we need to know the voltage here. To find that voltage, we need to know V. To find V, we need to know voltage across this and voltage across this. Now let me put my efforts to find the voltage and voltage here. But already how much current is given? 4R. Sorry, here 1 ampere. 1 into 4R will give you 4R. The same voltage will appear across even this element also. Because how these elements are connected? Parallel. Yes or no, all of you? This are parallel. No doubt in that. Okay. Now, you know the voltage here. Next, we need to find the voltage here. To find the voltage, you must require current here. To find the current here, you must know current and current here. You already know the voltage. Therefore, 4R by 4R will give you 1 ampere. To find the current here, 4R is the voltage here, right? And 4R by 2R will give you 2 ampere. 2 ampere plus 1 ampere will give you 3 ampere. 3 plus 1 will give you 4 ampere. 4 into 3 will give you 12R. 12R plus 4R will give you what? 16R. That's it. 16R by 2R will give you current 8 amperes. This is how you can solve the problems, okay? When you solve more and more problems, then you get the command over the networks. You have to put your pen on the paper and solve them. If you simply watch the solutions, you cannot get anything out of it, I'm telling you. Okay, meanwhile I just erase it. Note down that, all of you, quickly. Okay, so I think you already finished that, right? Now let us look at certain concepts and then fundamentals only. Okay, still we are in fundamentals. We have some more problems. We will see that one after that, but let us look at some important formulas here. Important formulas. We know how to define the current. Current is nothing but time rate of change of charge. Okay, this is nothing but slope of Q of t. Okay, let us write. If you know current, you can also find the charge. Charge at any instant. Current at any instant. Instantaneous current, instantaneous charge. Current at any instant, charge at any instant. If you know the charge, okay, waveform, then you can find the current at any instant or instantaneous current. Similarly, here, if you know the current, you can find the charge. What is that? Minus infinity to t, okay, I of t dt. We can write that minus infinity to t naught I of t dt. Okay, you must always remember the limits must be kept here. Without limits, it is not going to make any sense. Okay, so plus I can split this integration t naught to t I of t dt. Now look at this. When minus infinity to t, it is q of t. When in place of t, if you place t naught, it will become what? Q of t naught. Therefore, this will become q of t naught plus integration t naught to t I of t dt. This is called initial charge. This is called initial charge. Now look at this. Initial charge plus the area under I of t, okay, over the limits t naught to t will give you q of t. At any instant you can find the charge if you know the area under I of t over the limits t naught to t, plus of course q of t naught is also very important. Okay, this is very, very important formula. There's several occasions the problems are coming on the basis of this particular formula. Okay, so now one more important interpretation is very important in this particular case, that q of t, q at any instant is nothing but, okay, q at any instant is also called q between t naught to t plus initial charge. Q at any instant is nothing but, for example, q of 3, let us say. Q of 3 can be said as q of 0 plus area under I of t from 0 to 3. Or else q of 1, area under 1 to 3. Or else q of 2, area under 2 to 3. Like that you can write. Many ways you can write. Okay, so that is why charge between 0 to t is same as charge at an instant t. Both are same. Charge at an instant 3 is nothing but charge between 0 to 3. You understand, all of you? Okay, so this is very, very important. This is only for a charge. Wherever you have an integration or area, you have to, you can give the statements in this manner. Charge at an instant 3 is also same as charge between 0 to 3. Understand all of you? Okay. But current at an instant 3 is not same as current between 0 to 3. That is different again. Understand all of you? Okay. This is only for integration. When you have an integration, you can state like that. When you have a differentiation, you are not supposed to state like that. Okay. Now, third one. You know that potential difference between 2 points anywhere in the circuit. It is a work done on unit positive charge. To move that unit positive charge from A to B against the electric field, that is called voltage. Okay. Voltage or potential difference. Now power. Power at any instant can be defined as what? Time rate of change of energy or work done per second. But you can also write that dq by dq. Okay, dw by dq is nothing but voltage, dq by dt is nothing but current. So I can write it as what? V of t into I of t. Similarly, fifth one. Now can I write this one as a slope? Slope of W of t. Yes or no? Slope of W of t. Now can I write, if I know P of t, can I find W of t? What is W of t? Just like in this particular case, okay, I, Q, and if you know Q, you find I. If you know I, then you can find Q, and final expression is like this. Can I write the final expression something like this? W of t is nothing but Q of t is nothing but Q of t naught. Therefore, W of t naught plus, what is this? T naught to t, P of t dt. This is the initial energy. What is it? Initial energy. Now is equal to W of t naught plus area under P of t over the limits t naught to t. Okay, is nothing but W of t. Okay, please note down all these formulas which are very, very important. Okay, note down the formulas, all of you. Note down those formulas, all of you. One should have all these formulas on the fingertips, okay? And you should be in a position to apply whenever you come across a problem. You must be in a position to apply these formulas. And very frequently, you know, some questions have been asked on these basic formulas in GATE and PSUs and IES. Okay. You note down that. Meanwhile, I just write the problem here, okay, in the classroom workbook. Number 33. So I think all of you have noted down those formulas. Now, look at this question number 33, classroom workbook. Read the question carefully here. Determine the total charge entering a terminal between t is equal to 1 and t is equal to 2 seconds if the current passing the terminal is I is equal to 3t square minus 1 ampere. Okay. I is equal to given here 3t square minus 1 ampere. And time is between what? T is equal to 1 second and 2 seconds. Yes or no? Between. Now, look at this. Determine the total charge entering a terminal between. Okay, the charge between. The charge between, you can say, 1 to 2. This is T0 is 1 and T is what? 2. Yes or no? Yes or no, all of you? Look at this charge formula. Q of T is equal to what? Integration T0 to T I of T dt. Okay. Whatever the upper limit is there, that you are taking here Q of T. What is the upper limit here? T. Therefore Q of T. Suppose you have 1 to 2, then it becomes Q of 2. Suppose you have 1 to 10, then it becomes Q of 10. Yes or no, all of you? So, in your question, what is the lower limit? 1 second. What is the upper limit? 2 seconds. So, how can I write now here? Charge between 1 2 is also same as charge at an instant 2. So, be careful in the interpretation. I am telling you, this is applicable to the charge, energy, wherever you have the integrations, this is what the interpretation you require. Understand, all of you? Similar scenario we also investigate again in case of inductors and capacitors. There also you get the integrations. Yes or no? V is equal to L di by dt. But I, what will happen? 1 by L integral minus infinity to t V of t dt. That means wherever you have an integration, the interpretation must be like this only. Okay. So what is the upper limit here? T. T0 to t, then it is Q of t. 1 to 2, then it's Q of 2. Therefore, you have Q of 2. The upper limit you are supposed to take. What will happen here? Q of 0, or else 1 is already given T0, that is Q of 1 plus 1 to 2 I of t dt. What is I of t dt? 3t square minus 1 dt. This is how you are supposed to write. What is this actually here? Initial charge. But do you have any information regarding initial charge? No information. Okay, directly or indirectly did not give. But always have a practice, of writing this Q of t not always. Sometimes he will give all of a sudden, then you will be in trouble. It's always a good practice to write Q of t naught plus, okay, integration t naught to t I of t dt. This value is 0. Therefore, you have 1 to 2, 3t square minus 1. So what do you get here? Just integrate it. Okay, just integrate it. Okay, 3t cube by 3 minus t, you have 1 to 2. Okay, substitute here. What do you get? 3, that is 8 minus 1 minus, you can get now. What do you get here? T cube. This will be cancelled, right? So simplified, just substitute here 2 and 1. You will get answer here. Okay. Do that quickly. You can note down. This is cancelled. 2 cube minus 2 minus 1 cube. Okay. Minus 1. This is 0. 8 minus 2, 6 coulomb. Okay. Note down that. I think you understood that problem, all of you. (34) classroom workbook. Read that question. 34. How much energy does a 100-watt electric bulb consume in 2 hours? How much energy does a 100-watt electric bulb consume in 2 hours? So time is given T here 2 hours. Okay. Power is given here how much? 100 watt. Is asking energy. Okay. W is equal to P into T. So 2 into 100. 200, but watt hour. Yes or no? Watt hour. You can also write it as what? 0.2 kilowatt hour. 0.2 kilowatt hour. 0.2 kilowatt hour is also said to be a unit. Okay. So 0.2 units. Okay. 1 unit is equal to what? 1 unit energy consumption. 1 unit is nothing but what? 1 kilowatt hour. Okay. Sometimes you know the answer might be in joules. Okay. Joules means 200 into watt hour. Hour means what? 60 minutes. 1 minute is equal to 60 seconds. Therefore, what do you get here? Okay. 12 6 ja, 2 6 ja, 12 6 ja, 72, 1 2 3 4. 1 2 3 4. You can say 720 kilojoule. 720 kilojoule. Okay, you can express the same thing either in kilojoules or joules or units or kilowatt hour or watt hour. Okay, well, question number 35. Okay, question number 35. Question number 35. Hope you have all of you noted down this, right? Note down that quickly. You can express the energy in joules or kilowatt hour or units, anything. Read the question here. The charge entering a certain element. The charge entering a certain element is shown in the following figure, right? The charge entering a certain element is shown in the following figure. Right? Find the current at A, t equal to 1 millisecond, B, t equal to 6 millisecond, C, t equal to 10 millisecond. Understand all of you, okay? So first we do a normal procedure, generally how we do it, and then we even look at the simple way of solving the problem, okay? And I think all of you noted down this, right? So let me erase it. So you would like to find the current given the charge waveform, okay? You would like to find the current. What is the current and charge relationship? dq by dt. But what is charge actually? How you define it? You define it, it's a line passing through the origin. Actually, this value is given. You please note down that it's already shown in the figure. It is 80. Okay, this is 80, right? So this is 80. So how do you define mathematically this particular charge to differentiate it? So charge is 0 to 2, a line passing through the origin, y is equal to mx, then 0 slope, constant value, then negative slope, right? So let's find them, okay? Q of t is nothing but 40 by 2, that is 80 by 2, that is nothing but 40 t, but for t between what? 0 to only 2. And next what? 2 to 8. This is what 8, right? Okay, this is what 8, right? So 2 to 8, you have constant value. That is 80 for t between 2 to 8. Now I need to find the equation. This is 8 comma 80. This is 12 comma 0. Yes or no? Then we can find that equation. Y minus y1 is equal to m into x minus x1 is the formula for a straight line equation, right? So q minus 80 is equal to, okay, y2 minus y1, 0 minus 80 by 12 minus 4, 12 minus 8, okay, 12 minus 8 and t minus 8 here. So what do you get here? Minus 80 by 4 is nothing but minus 20. Minus 20t minus into minus plus 160. That is finally here you got, okay, here you got, finally you got here q of t is equal to minus 20t plus 80 plus 160, 240. This you substitute here. What do you get? Minus 20t plus 240. This is for t between 8 and 12. This is how generally you define any given waveform mathematically, right? Then, if you now go with a charge, what is the charge actually here? Sorry, charge is given but current, right? What is the current now? Charge is known dq by dt, right? dq by dt, it is nothing but, when you differentiate it, this is 40 for t between what? 0 to 2. Then 0, differentiate it, right? 0, 2 to 8. Then it is minus 20. This will be constant, 0, right? Then minus 20 for t between 8 to 12. This is a standard procedure. Generally, when you have a waveform, you define it mathematically, then you differentiate it. Yes or no, all of you? But what is I is equal to dq by dt? dq by dt is nothing but what? A slope, right? Let's try to find directly when charge versus time is given. When you find the slope, you directly get the slope is nothing but what? 40 ampere. Here directly what is the slope? Slope is nothing but what? 0 ampere. Here what is this? Slope. Okay? Minus 20 ampere. I can take directly ampere. Why it is? Because millicoulomb by millisecond. Milli get cancelled. Coulomb per second is nothing but ampere. Okay? I can also even construct. It is not asked in the exam, in the problem. Okay? It is not asked in the problem, but I am doing it. Just we'll try to construct the current waveform for a given charge waveform. I of t will be in amperes. Time is still in millisecond only. Okay? Now, if you just take this, look at this. From 0 to 2, what is it? 40 ampere. Now, 2 to 8, what is it? 0. Okay. Then 8 to 12, what is it? 20. Yes or no? This is 20. Okay. Minus 20, that is not 20, but minus 20. Minus 20, that's it. This is 4, this is 6, this is 10, right? Okay, this is 12. You understand? For a given charge waveform, the corresponding current waveform is this. That's it. Please note down. So I think got the answer. What is the current at time 1 second? 1 second is here. What is the current? 40. Okay, you got 40 here. Right? Here 0 ampere. Here minus 20 ampere. See this? 6 means 0. 10 means minus 20. That's it. Classroom workbook 36. The charge flowing in a wire is plotted in the following figure. Sketch the corresponding current. Okay, I think all of you read that question. Okay, the charge flowing in a wire is plotted in the following figure. Sketch the corresponding current. Okay, so let me just draw that waveform given. All of you have the problem with you. 0, 1, it's not 1, it is 2, 4, 6, 8. So t in second, and charge is given in coulomb. This is what 50, and this is what minus 50. Okay, the lower limit is minus 50, the upper one is 50. Okay, so he's asking the charge versus time and then asking us to find the current. Okay, so what is the relation between current and charge? I is equal to dq by dt. Just now we have seen it is nothing but what? Slope of q of t, right? So let's go for the slope calculation directly instead of again, line with a negative slope. Again, you need to find the equation. Don't waste time. Okay, just now we have seen even the standard procedure, but that is only to make you understand, but that's not required. Directly you attack the problem with the slope calculation here. What is the slope? 50 by 2 plus 25 ampere. Why I'm taking plus? Because the positive slope. Then here, what is the slope? You get negative. You can calculate it. 2 comma 50, 6 comma minus 50. You can do that. You will get negative slope. So minus 50 plus 50, that is minus 100 by 4. You will get a minus 25 ampere. Similarly, this one also 6 comma minus 50 and 8 comma 0. They can find it. Slope will become plus 25. Okay, so now I can sketch the corresponding current waveform here. Okay, this is 2, right? This is 4, right? And this is what? 8. So 2 is plus 25, and this is 2, 6, right? This is 4. You can see this is 4. And plus 25, then minus 25, then again what? Plus 25. That's it. So this is 8. Plus 25. This is minus 25. This is current in ampere. This is time in second. Please note down this, all of you. So I stop the session here, but please note down all these things. Please note down all these things, and after that we will step into another session. Okay. I stop the session here. We'll meet in the next session. Okay.